Sets and counting. So the first section in this unit are just going to be talking about some notation and whether or not events are going to be independent or dependent. So in our first example, we're going to talk about independent and dependent. So whether one event would affect the other. So our first one here in example 1 would be rolling a 2 on a die and rolling a 5 on another die. So what you would just ask yourself is, if you roll one die, is it going to affect another die? And so you're not going to get too complicated here and say, well, if they touch each other, if they roll into each other, you're not going to worry about that. Is if you're just rolling two completely separate dice here. So these would be independent events. So are the events independent? So the first one would be yes, these are independent events because rolling a 2 on a die, rolling a 5 on another die, they would be independent. They do not affect each other. All right, for B, getting dealt a full house in a game of poker. So if you're playing a game of poker, so getting a full house would be 2 of one kind and 3 of another kind. So that would be like getting 2 7s and 3 10s, or 2 aces and 3 queens. So just 2 of one kind, 3 of another. And that would be no. That would be not be independent because you have to get certain things. Like if you get an ace, then that means that there are only three aces left in a deck of cards. So that means there's less aces left in that deck. So that would be dependent. Those are not going to be independent events. All right, so for C, choosing a red marble from a jar and flipping a coin on the head. So those are two completely separate things. So those are going to be independent events. All right, for D, selecting a red marble, selecting a red, a blue, and a red M&M from a bag without replacement. So without replacement means you're not putting it back. So if you're not putting it back, there's less M&Ms in the bag. So those would not be independent events because if you have less M&Ms, there's less to pick from in the bag. And E, drawing an ace and rolling a 6 on a die. So since those are two separate things, those are going to be independent events. Okay, our next thing that we're going to talk about, and this is our notation. So what we're looking at here, this symbol means what is like an and. You can kind of think of this as like an and, what they have in common. And then this symbol here, you can kind of think of it as like an or. So it would be all. You would list all the elements from sets A and B. And this can be anything. So in example 2, I keep it simple. We just do a set of numbers, okay? So set A is the set of numbers 1, 3, 5, and 8. Set B is the set of numbers 3, 5, and 7. Set C would be 2, 4, 6, and 8. We could also do, just for an example, we could say that set A would be like the colors red, blue, and green. Just as an example, I could say that set B would be the colors pink and red. And I could say that set C would be the colors blue and black. Okay? So your sets, when I'm talking about sets can be anything. Okay? It's just for this example, I keep it simple and short, and we just use numbers because it's quick and easy to write. Okay? So for our first example that we're going to use, we do A and B. So what do A and B, what numbers do A and B have in common? Well, A and B have in common, they've got 3, they've got 5. So our answer would be 3 and 5, and we put them inside these curly brackets. Okay? All right, then our next example for B, it uses this symbol. So that means, remember, if we refer back up here to our example, we do all, okay? So we list everything from A and B. Okay, so we would list, and I would just do it in numerical order. I'm going to do 1, 3, 5, 7, and 8. So I'm listing all the numbers from A and B. Now C is a combination. So what I'm going to do first is I'm going to kind of treat this like order of operations. So I'm going to do my parentheses first. So in this one, I'm going to list everything from A and C first. So I'm going to do that first. It's like a two-step process. So I'm going to list everything from A and C. So that's going to be 1, 2, 3, 4, 5, 6, and 8. Okay, so this A and C is this set right here. And so now what I'm going to do is I'm going to list what does this set have in common with set B. So I'm looking at this set of numbers and I'm going to see, well, what does this have in common with B? So I'm comparing the set of numbers I just wrote down to set B. Well, the only things they have in common would be 3 and 5, and they don't have a 7. So my final answer would be 3 and 5. And so that is my final answer for C. Okay, so then we get to complements. And complements in math, the way that this is spelled, is the element not in the set. And the way that that's represented is you see like this line right here above it. So that means the complement. We're taking the complement of it. And so you always compare it to the universal set, okay, the universal set. So you will be given, in any scenario, you will be given a universal set. So in this case, the universal set is 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, it could vary from problem to problem. So a universal set could be a set of colors. A universal set could be like a set of names. A universal set could be, it could be anything really. But like I said, for this purpose, I just did a set of numbers because it's short and sweet. So in set A, what you do is you compare set A, you compare it to the universal set. So what is A missing that the universal set has? So it has 1, but it's missing 2. It has 3, but it's missing 4. It has a 5, but it's missing 6. It has a 7, but it's missing 8. And it has 9, okay? So A is missing the 2, 4, 6, and 8, okay? All right, so now we look at what is B missing. So B has 1, 2, 3, 4, but it's missing 5, 6, 7, 8, 9. So that's what it's missing. Now, on C, what we do is we kind of do like order of operations. So the first thing I'm going to do is I'm not really going to worry about the complement first. Okay, I'm not going to worry about that just yet. What I'm going to do is I'm going to do this part first, okay? I'm going to do A and B first. So A and B, what do A and B have in common? Well, they have the 1 and the 3, and that's it, okay? Now what I'm going to do is I'm going to do the complement. So I'm just going to, whoops, I didn't mean to do that. Okay, now I'm going to take basically the complement of 1 and 3. So what is that missing? Well, it's missing the 2 and the 4, 5, 6, 7, 8, 9. I'm comparing it to the universal set, and that's what it's missing. Okay, so then the next step, I'm going to follow like the same steps. I'm going to do this part first. So basically, I'm going to take everything between A and B, which is 1, 2, 3, 4, 5, 7, and 9. And now I'm going to take basically the complement of this. So what is this missing? Well, it's got 1, 2, 3, 4, 5. It's missing 6. It has 7, and it's missing 8. So that's the answer to that one. Okay, so now on this one, these are a little bit different. So I'm going to do the complement of A. So the complement of A, which I've already done in up here. So up here. So the complement of A, remember, was 2, 4, 6, and 8. And then remember the complement of B, I did right here, was 5, 6, 7, 8, and 9. And now I take everything, because I'm looking at this right here. That means all of them together. So basically, it's kind of like you add them together. It's like everything combined. So that would be 2, 4, 5, 6, 7, 8, 9. Okay? Okay. And F is the toughest one of all. So if you want to pause this one and try this one just for fun on your own, you can. So the first thing you do is you're going to do this part first, which was just this, 2, 4, 6, and 8. And you see what does it have in common with just B. So I'm going to look at this and see, and I'm going to go up here and look at B, which was just 1, 2, 3, 4. So A and B, or the complement of A and B, would be 2 and 4. And now I take the complement of that, which would be 1, 3, 5, 6, 7, 8, and 9. So you kind of have to break these down and do them in steps. Okay, so now let's get to our counting formula, also known as the addition formula. And this is something you will see. It'll happen. You'll see this again, like on the ACT and the SAT. You'll need to know this one. So what you do, if it ever asks for a probability, so if it wants to know the probability of like an OR, you take what something has in common in a set, in each set, and you have to subtract what they have in common together, okay? So, for example, if you have 15 in set A and 20 in set B, and 10 are in both set A and set B, how many are in set A or B? So basically, we're just substituting in here. So we would do 15 plus 20 minus what they have in common, which is the 10. So 15 plus 20 is 35, minus 10 would be 25. All right, B is similar, so except this time we want to find just what's in set A. So basically, we have A plus B is 20, and then what they have in common is 10, and this time we set equal to 50. So we have 20 minus 10 is going to be 10, equals 50. If I subtract 10 from 50, I know set A has 40 in it. Okay, looking at Venn diagrams. And this is very important to know how to read, because I've seen with the election and everything, I've seen a lot of Venn diagrams out there. So use the info in the given figure. So how many are in set A? So what you want to do is you want to look in the whole circle of set A. So what you want to do is you want to add up all the numbers in set A. So 15 plus 3 plus 5 plus 2, which should give you 25. Okay. All right, let's erase those. All right, how many are in set A or B? Okay, so this means you are looking at all of these numbers here. So you're adding up 15, 3, 5, 2, 2, and 10. So you don't want to add up those numbers twice that overlap. You just add 15, 3, 5, 2, 2, and 10, which should give you 37. All right, how many are in A but not C? Okay, so if you want to know how many are in A but not C, we're going to add up 15 and 3 because we don't want to count the ones that fall in circle C. So that would be 18. All right, how many are in A, B, and C? So the key word here is the and. So it's overlapping. It wants to know the overlap. It's using that word and right there. So it just wants to know that 5. Okay, I'm going to add a question. How many are not in A and B and C? And I guess I should have wrote that out. But once again, emphasis on the ands here. And it would be the 4 that's outside. Okay. Basic probability, which most of us know this. Number of favorable outcomes over the total number of outcomes. So tossing a fair coin, list the sample space for the outcomes of tossing 3 coins. So a sample space would just be, what are your possibilities of happening? And what this would look like would mean that you could get heads, heads, heads. You could get heads, heads, tails. You could get tails, tails, tails. You could get tails, heads, heads. You could get tails, tails, heads. You could get heads, tails, heads. You could get tails, heads, tails. And you could get heads, tails, heads, tails, tails. So these are all the possible outcomes that you could get. So the probabilities that you could get all heads is 1 out of 8 because that only happened one time where we got all heads. The probability that we got 2 tails happened 3 out of 8 times. Okay, because we had a total of 8 possibilities that happened, and 3 times we got 2 tails. The probability that we got no heads was 1 out of 8 times. And the probability that we got at least 1 tail was 7 out of 8 times. Okay. A bag contains 6 red marbles, 4 blue, 2 yellow, and 3 white. 1 marble is drawn at random. List the sample space. So your sample space is going to look like this. You have 6 red. So you would do 6 R's. You would do 4 B's. You would do 2 Y's. And 3 W's. That would be your sample space. So your following probabilities, the probability of red would be 6 out of 15, which would reduce to 2/5 because you have 15 total marbles and 6 of those are red. Now, blue or white would be 7 out of 15 because you've got 4 blue and 3 white. That's a total of 7, and 7 over 15 does not reduce. Not yellow, so you have 2 yellow, so 15 minus 2 is 13. So that's 13 out of 15. Okay, and for our last example, let's talk about a standard deck of cards because a lot of probabilities are based around a deck of cards. So let's just talk about what a deck of cards consists of. So in a deck of cards, you have 52 total cards. And we have 4 suits in a deck of cards. We have spades. We have clubs. We have diamonds. And we have hearts. And if you didn't know this, spades are black. Clubs are black. Diamonds are red. And hearts are red. And there are 13 cards in each suit. You have an ace, because you got a 2, 3, 4, 5, 6, 7, 8, 9, 10, a jack, a queen, and a king. Okay, so the probabilities for a deck of cards. So the probability that you would get a heart would be 13 out of 52, which reduces to 1/4. The probability of a black card would be 26 out of 52, which reduces to 1/2. Probability of a 2 or a jack, so you would add up all your 2s or your jacks, which would be 8 out of 52, which would be 2 out of 13. And the probability that you would not get a spade would be 39 out of 52, which would be 3/4. So that concludes our notes, our first section on probability.